All right, welcome to today's lesson on section 1.2, which is solving linear inequalities. Before we get too far here, as we're going to try and do throughout this year, we want to think about what do we mean by an equation, what do we mean by an inequality. When we say something like 4 equals 4, that's a pretty obvious statement, right? Of course 4 equals 4. How would we represent 4 equals 4 on a number line? Well, or how could we use the number line to understand that? It's not difficult at all. Here's 4. It's in the same spot on the number line. Therefore, they're equal. Okay? Hopefully nothing earth-shattering there. Now, what about this, though? When we say 4 is greater than 2. Well, what we mean by that is that 4 is further to the right on the number line than 2, which is right here. That's what we mean when we say 4 is greater than 2. So this number line gives us a visual for what these things mean in the context of the mathematics. So let's move over to this number 1 here. Let's describe what x greater than negative 2 means verbally and represent it graphically. Well, x greater than or equal to, x greater than negative 2 means all numbers, let's go with black here, all numbers greater than negative 2. And so you ask yourself, well, how would you represent that graphically? It's like, well, this statement is saying all of these numbers that are greater than negative 2. So you think like, well, is 0 greater than negative 2? Yeah, because here's negative 2 on the number line. 0 would work, right? 2 is greater than negative 2. So this means all numbers that are to the right of negative 2. How do we represent that? Well, we can represent it with an arrow. Okay, we don't actually have to put dots at every single number on the number line. We write an arrow that says, hey, everything this way or this way, that's what we mean when we say x is greater than or less than something. All right, so let's continue on here and actually do some problems. Back over here to number 2. Solve the inequality and represent the solution graphically. Now, something that you should do in mathematics sometimes is think about what is your solution going to look like before you actually tackle the problem. So y minus 6 less than 3. Well, let's think about what numbers might be possible solutions. How about 0? Does 0 work? Sure, if you plug in 0 here, you get 0 minus 6, which is supposed to be less than 3. And negative 6 is less than 3. So yeah, 0 is a number that would work, right? And you might think, like, well, what about 1? 1 minus 6 is negative 5. That's less than 3. Great. So, okay, so these numbers over here seem to all be fine. It's like, how far up do we go? Well, we can figure this out algebraically. We can just add 6 to both sides. Got ahead of myself. Add 6 to both sides, and I get y is less than 9. Okay, so my actual answer then, we can just represent on the number line in this way. We can just say, start at 9. Put an open dot there because we don't want to include 9. We've got this is a less than symbol. It is not greater than, or sorry, it's not equal to. So we'll leave an open dot there, and we want everything that's this way on the number line. Right? Fantastic. Let's go on to the next one here. Solve the inequality and represent the solution graphically. So here, we want to solve this for x. Now, what you might think to do first is to divide both sides by negative 4.2. And that wouldn't be too bad, but I'm just going to divide by positive 4.2 so we can look at what's going to happen when we divide by a negative here in a second. So divide by 4.2, 4.2. I get this. Negative x is less than or equal to 6. No, I'm sorry, 7. Okay, so we have this negative x less than or equal to 7. The question is, what do we do with it, that negative? Well, if I multiply both sides by negative 1, we can get into this more in class maybe if you're really curious, but if you times those sides by negative 1, it essentially takes the number line and changes the sign on every number, which flips it. Okay, so when you do that, you also, the way to fix that instead of just flipping your number line around somehow is just to change the direction of the inequality. So what we get for our final answer then is x greater than or equal to 7. Okay, and then to represent that on the number line, we just put 7 on here. It's greater than or equal to, so we have a solid dot, arrow pointing to the right. All right, let's do some couple more problems here. So, number 4. Solve the inequality and represent the solution graphically. All right, well, you'll find now that inequalities behave much like equations with that one exception. When you multiply or divide by a negative, you have to change the direction of the inequality. All right, so to solve this one, I would first clear out the fraction. I would times both sides by 6. And I would get 5x plus 58 is equal to negative 24x. I'm going to subtract 5x from both sides. And so when I do that, I'll get negative 29x is less than or equal to, I already subtracted this off, 58. And then I'll divide both sides by negative 29. And I get x is less than or equal, greater than or equal to, got to switch the direction of the inequality, negative 2. Okay. And then obviously to represent that graphically, you just sketch it out on the number line. All right, the next one you should try on your own. I'm going to speed up the video here and you can check your answer. So pause it, try it, and I'll have the answer here in just a second. So hopefully you got number 5 okay. Let's go on to number 6. Define a variable and set up an inequality. So now we have words and we want to turn it into an inequality. This is how we do that. The difference means subtraction. So we have the difference between 4 times a number. So when I see that, I'm thinking a number would be x, so this would be 4x, 4 times a number. And 15 is less than 21. So I know I've got this, is less than 21, so I've got that. And then this 4x, so it's the difference between 4x and 15. When you see the word difference or sum, you go in order of what is written after that. So it will be 4x minus 15, not the other way around. So there's an expression based on a statement, or there's an inequality based on a written statement. So let's do the last problem here. Salem has a website that earns $15 per month plus 5 cents per advertisement click. If she wants to earn at least $50 a month, then what is the least number of clicks that she needs? So what we want is she gets 5 cents per click. Okay, so every click, that's going to be our x, okay, is the number of clicks. So what her amount earned, sometimes it's helpful for word problems to write it out in words first. Her amount earned is going to be greater than or equal to $50. That's what she wants. She wants greater than or equal to $50. And so her amount earned, we need an expression for that. Well, the expression will be $15 per month plus everything she earns from clicks. That'd be 5 cents, so 0.05, times the number of clicks. All of that has to be greater than or equal to 50. And if you solve that inequality, what you'll get is that she needs at least 700 clicks. So you get x greater than or equal to 700. And so Salem needs at least 700 clicks there to earn $50 a month. And that's it for section 2.2.